Okay, let's go down the build list here. We've got a Revision B Raspberry Pi. We've got a basic, you can see this USB dongle. It's not the greatest shot, but it's a E4000 chipset in there, used for HD TV reception. It came with a pretty poor antenna, and if you want to use this device as an SDR, you're going to have to replace that almost immediately. The first couple of times I had this powered up, I thought it was not working, because the antenna that it comes with is so, well, it's about as big as a pencil, and you probably get as much reception from that. So we've got this doing basic output. I've got a Ras Debian variant on here, the most common one that people are using out there. I'm sure this would work with Fedora or some of the other releases as well. Let's go over to the computer. There's a little bit more connected to this than I probably would want in the field. Obviously I've got a USB hub connected. That's because the adapter and dongle is a little bit big, and keeping a keyboard plugged in at the same time to just at least get the initial stuff fired up. I had to make room. Eventually I'd like to script this, but that will come at a later date. So over to the actual interface on the Raspberry. So I'm going to stop the process here. It's actually capturing in the other room, so let it stop here, and let's get it started again. So you can see I'm using RTL TCP, and I'm just using my local LAN address. So we're going to fire this up. You can see found Electronics E4000 device, and it's waiting now for input. So I'm going to stop the video for a second, run over to my other machine, and we'll pick it up from there. So at this point, this radio is operating. Okay, so now this is on the other PC's side of things here. So the Raspberry Pi is working kind of as the radio server, if you will, and then this is the client software. So for this demo I'm using SDR Sharp, which is a free application that will work with RTL TCP. It's a Windows-based app, but I believe it's out for some other stuff as well. The Raspberry Pi does not have enough power to really run the receiving end, a GUI, and this software package, especially the waterfalls and stuff like that, are just too much. So what we're effectively doing is having it pipe out that data over TCP to this system. So the first thing I'm going to do here, and I apologize for the shaky video, I'm sure there'll be comments on that. So we'll go into configure, and it's pretty straightforward. There's not a whole lot to configure on this. It's just the IP address of the Pi itself on my network, and the port, the generic port that it starts with is 1234. That's changeable on both sides, so you could get to something a little maybe more unique than that. And if you wanted to have multiple instances of this stuff running, potentially you could maybe do that as well. So let's update that setting and close this, and we will now attach to the Pi. So I've already got it tuned in here. Let me turn down this volume. You can see we're getting pretty good refresh on this waterfall, and so we're able to scan across the band right now. I just have us on some radio or some weather band radio. You can see my audio is pretty good. Let's see how cold it's going to be in Minnesota. So you can see I'm getting pretty good reception, pretty good audio here. If the handy hams get on later tonight, maybe I'll get some video of that put up too. All in all, it didn't take me too long to get this set up. It was a little extra work on the Pi. The compile times weren't too bad. More details on that below. Hopefully I'll throw some of that in the comments area. I'll get some links sent out so people can start using their Pis as radio receivers. Thanks everybody.